Hello again. In this video we are going to see different kinds of powers, the powers that having rational exponents. We saw in the previous video that the powers having natural exponents. In this kind of powers we have rational exponents. What do you mean by rational number? Rational numbers are any number of the form a over b, where a is an integer and b is a non-zero integer, where a is integer and b is also integer but different from 0. So like 3 over 2 or minus 1 over 4 and so on. These are called rational numbers. Let's see this activity to understand the kind of radicals. Perform the following expressions. Radical 3 squared. All we know that radical 3 squared is 3. And also 3 squared, this is the same number. If we raise it to the power half, and according to the properties of exponents and powers, we multiply 2 by half, which is 1, so it will be again 3 exponent 1, which is also 3. So ask yourself, what can you deduce from these two equations or these two expressions? We simply can deduce that this radical here actually is nothing but the exponent, or raising the number to the exponent half. So indeed, if we see radical 7 squared, when we put radical for the 7 squared, actually we are doing what? We are raising it to the exponent half. That's why it will be 7 to the exponent 2 times half, which is 1, which is 7. But we got used to do it directly. Radical 7 squared is 7. But here we are discussing the detail why we remove the square with the radical in this case. This kind of radical is called the square root, or the radical or square root of a number. Let's say if we have radical 5 without squaring, actually this is nothing but it is raising the 5 to exponent what? To the exponent half, which is 5 exponent half. For that reason they use this way of writing. Instead of the exponent form, we are writing it in the radical form. Other kind of radicals that we can see is this kind of radical, which exists on the, you may use calculator to perform this, which we call it the cubic radical. Here this number is called the index, or the order of the radical, 4 exponent 3. You can use your calculator, it will be 4, while 4 exponent 3, raising it to the exponent 1 over 3, so as you know, 3 times 1 over 3, which is 1, 4 exponent 1, which is again 4. So this kind of radical, when we put this kind of radical to a number, actually we are doing what? You can understand what? From the second equation, you can notice that this kind of radical is nothing but raising the number to the exponent 1 over 3. And this kind of radical is called the cubic root, since it has an order 3. What about the previous one? Why it is square root? Actually, there is nothing here, but this doesn't mean that there's 1 at this place. Actually, there is 2, but we may omit it. There is no need to write it, since this kind of radical is the most used radical in science, in mathematics, and other subjects. And using calculator, I can show you where can you find this kind of radical to perform some calculations. Okay, before we go to the other slide, if you have this kind of this type of calculator, you can see here the golden writing. You have to put shift, and this kind of radical you got the cubic root of what? Of, let's say, 4 exponent 3, pressing equal, we get 4. So, and we can check it for other numbers. Let's say cubic root of 8. So it will be what? If you think about 8, you can write it as exponent or power of 3. So it is 2 exponent 3, right? So it will be 2. That's why I can explain it in another way. If you write cubic root of 8, actually cubic root 8 itself is 2 power 3. So, and as I've told you, this radical, this one, is raising the base, which is 2 power 3, raising it to the power what? 1 over 3. So it will be 2 exponent 3 times 1 over 3, which is 3 over 3, which is 2 exponent 1, and we can simply write it to just 2. That's why the calculator gave us cubic root of 8 is 2. And we can continue in this manner to the other kind of radicals, like fourth root of something, which is raising the number, the base, to the power 1 over 4, and this is called fourth root, or the radical with order 4. This is the fifth root, and in general we may call it the nth root, where n should be a natural number greater than or equal to 2. It cannot be 1, it's 2 or more. So the general form, if we have a general form like this one, you can see nth root of a exponent m, it's nothing but raising a exponent m to the power 1 over n, remember, 1 over n, which is a exponent m over n. I want you to focus on this. How do we change from the radical form to the exponent form? Remember, the exponent of the base, the number under the radical, which we call it radicand, the exponent still, we keep it in the numerator, and the index of the radical, we put it in the denominator of the fraction, so that the base a is raised to the exponent m over n. This is the main idea of this part of this chapter. Again, the radical form, this is called the index, as I told you, order of the radical. The radicand is the number, the thing under the radical. This is it. The properties, all these properties are already known in the natural exponents. We can use them in the rational exponents. Okay, this is it for this video. Bye bye.